Welcome back everyone to the Hello World Guide. This is another episode of the OpenGL 3D renderer series, and if you remember, in the last video we created this vertex shader and this fragment shader, and we wrote those shaders as strings, and in this video we are going to compile these shaders. Now if you remember, in the last video I said that we are using modern OpenGL here, and if you want to use modern OpenGL, sadly it does not, you will need to use some library like GLEW.h. So you can see I am including this. The reason is that the modern OpenGL functions are not present by default but need to be loaded dynamically. For that we use GLEW, and of course I have installed it with VC package, so dependencies are automatically initialized. So we are going dependencies are, it tells Visual Studio. So we are going to initialize GLEW by saying GLEW init, and if its return value is not equal to GLEW underscore OK, which is a constant defined in GLEW.h, then we are going to include IOStream here and give an error to the user. So yeah, by the way, there are other libraries for loading stuff, and of course you can do it manually, but doing it manually means different for different systems, and you can use this library to use that, and of course you can use some other libraries as well. The basic purpose is that it will load all of the things for you. So we'll say fail to initialize GLEW if it does not work, and return with -1. So that is going to have GLEW initialized for us. Now what we need to do is, by the way, if I open up GLEW, you can see it contains all of the different constants and all of the different constants that OpenGL has, and creates definition for all of the functions that OpenGL contains. However, for the functions that are present in modern OpenGL, not present in old OpenGL, it will basically load those functions dynamically, and we'll see an example of that in a second. So for now, let's so you can see it had a bunch of defines with different function names, so that's how we'll use these functions. So now for actually creating our shader, what we'll need to do is we'll need to say we'll use a function which returns a value of unsigned integer, which we can represent using size underscore t or uint32 underscore t. We're just going to say size underscore t, and for the name we are going to say vertex shader. Yeah, let's just call it vertex shader. So vertex or vertex shader, actually, not just vertex, and we'll set that to a function called GLCreateShader, which returns a size underscore t and an unsigned integer more properly, and we are going to pass for the shader type we are going to say GL underscore vertex underscore shader, and this will create the shader for us. Now if I go here, you can see it is implemented as a hashtag define, which uses a macro called GLEW get function with underscore GLEW create shader, which is basically a pointer and to a function pointer to a function with that particular type definition. So it's basically, that's the way GLEW works. So we can use those easily, those functions here easily, and if you do not initialize GLEW, it will give a null pointer exception. So now what we need to do is we first need to specify the source code for our shader before we go ahead and compile it. So for the shader, we'll just pass the vertex shader, of course, and for the count we only want to compile one shader, and for the actual string representing that, we'll have to say vertex shader code, and for this length we don't want to obtain that, so we'll just pass in null pointer here. By the way, we need to pass an address to the string and not the actual string itself. So with that, we have got our GL shader source here. Now we can just compile the shader. So we'll say GL compile shader. Yeah, let's just say that. And GL compile shader will compile the shader, and it only requires us to provide the actual code of the shader, which is vertex shader. So after we have compiled the shader, of course, it might contain some syntactic or other kind of errors, and it might fail to compile. For that, we'll create a variable int called success, because OpenGL will return an integer code for whether it succeeds or not. So we'll create an int called success, and we'll say GL get shader IV. For the actual shader, we'll pass in vertex shader, and for the type or the name of what we want to get, we'll say GL underscore compile underscore status, which will get whether it compiled or not. And for the actual parameter that we want, we will pass in the address for our success, a pointer to success. So we get that, and if not success, which means it's not equal to 0, which means it's failed essentially, we'll create an array called info-log, and this needs to be the amount of characters that we could expect the error log to be. So we'll just say 1024 for now, which is pretty big, it should not cause any problems. So now we can get the info-log, which will we'll say GL get shader info-log, and that will help us find out what error occurred. So we'll say vertex shader for the shader, and for the actual size, we'll say 1024 since that's the buffer size, and we'll just pass in length pointer for length, and for the actual info log we'll just pass in the info log. And now it should automatically write the data to the info log, and then we can just output it using error. We can say failed to compile shader, and we can just go ahead and say for example let's say a new line, and then we can say info log colon and then another new line, and then we can output the info log. Or actually we can do it in the same line. We don't really need to create a separate statement, so we can just say info log after that, and that is going to take care of the problem for us. So it should allow us to output the info log. So that is going to be pretty simple, and the fragment shader is basically the same thing. We can just change the vertex to fragment for actually creating the shader, and we don't need to redefine success, or actually we could define info log at the top once as well. We don't really need to do it twice inside of each if statement. So let's just do that, and yeah, that's pretty much it. That's going to have our vertex shader compiled as well. One thing we will need to do is we will need to change this shader from gl_vertex shader to gl_fragment shader. So we can just say fragment here, fragment shader. Actually not this, it's not working right now. So yeah, that is going to compile the fragment and the vertex shader correctly, but there is still a problem, which is that these shaders are compiled separately. We've got a separate fragment shader and a separate vertex shader. Now it is time to link these two shaders together. So linking a shader into a program is our next step. We'll need to create another unsigned integer called shader. We'll just call it shader, and this is going to be a shader program, which means it's going to take both the compile shaders and combine it together. So we'll just say gl create program, and once we have created it, what we'll do is we'll need to basically we can say attach shader. So we'll attach different shaders to this program. So for the program we'll just pass in our shader, and for the actual shader we'll say vertex shader, and we'll also say fragment shader. So we'll attach both of these to the program, and then we can just say gl link program, which will link the program. So of course we have already compiled the shader, so we'll need to link them into a program called shader that we have given the name of shader. So that's pretty self-explanatory, and of course we'll need to check for errors, which is done in a very similar way. Instead of gl get shader iv, we'll pass in the actual program called shader, and we'll say use gl get program iv, and we'll say gl link status instead of compile status. And for the actual get info log, we'll say get program info log, and we'll pass in our shader instead of the vertex shader. And we'll, instead of saying fail to compile shader, we'll say fail to link shader. So that is pretty awesome. We have gotten our program, and we have linked it, and we've got our shaders. Now that we have linked our shaders with the program, it's not really necessary that we keep those shaders. So we can just discard those shaders using gl delete shader, and we can pass in both our vertex shader and the fragment shader, because we don't really need those anymore. So we have got now an unsigned integer called shader that we can use to draw different stuff on the screen. So yeah, this is pretty much it for this video. In the next video we are going to actually get started drawing stuff with this shader, so stay tuned for that. I'll see you in the next one, and make sure to like and subscribe as well, and share this video with other people, and bye.